Right, this is quadratic equations, and these questions are quite short, especially compared to the ones we did with linear equations with fractions. So first of all, yes, you do need to know how to do quadratic factorization, and when we look at this first one, this is actually already factorized. Now, this is like a very common mistake. When people see this question, they just go like natural tendency to start multiplying out the brackets. But remember the aim, or we'll see that our aim is going to be to actually put it in a factored form. Now, just to backtrack a bit, why do we want it in a factored form? There's a certain principle that we're going to use to solve these equations. So if I have two numbers, let's call these two numbers A and B. So if I times these two numbers and I get my answer, and if my answer is equal to 0, the fact is that in order to get to 0, either A or B must be 0. You can't like multiply two numbers and get 0 unless one of them is 0. So either A must be equal to 0 or B must be equal to 0. And we use this principle or this fact to solve quadratic equations. So we put them in factors, we factorize them, and then we say, okay, either this factor must be equal to 0 or this factor must be equal to 0. And that allows us to solve quadratic equations. Now, quadratic equations you'll also see has two solutions. And just to show you the basic ones, like when it's not in factored form, you'll see that you've got a term with x squared somewhere in the equation, and that indicates that it's a quadratic equation and that there will be two solutions. Whereas linear equations only have terms with x's in it, and therefore it only has one solution. And similarly, that equations that you'll do in matric, that's got a x to the power 3 to it, cubic equations, and they will have 3 solutions, and so on. So going back now, we'll just do the ones that are already factored, and then we'll move on to the next ones where we have to factorize first and then solve. But yeah, if you can do your factorization, this is really peanuts. This is really easy. So that principle that we said, where if we multiply two factors and our result is 0, one of them must be equal to 0. So we're going to say x minus 2 is equal to 0, or x plus 4 is equal to 0. Because, yeah, one of them must be 0. So then we solve. This is like a Mickey Mouse linear equation. So then we just solve for that. So x equals to 2 or x equals to minus 4, and we're basically done. So, okay, going to B, just that example. So these are already factored. So either 2x minus 3 equals to 0 or 4x plus 5 equals to 0. Solving for that, take the 3 over, 2x equals to 3. So x is equal to 3 over 2. And then this, 4x equals to minus 5. And x is equal to minus 5 over 4. Now, this seems like just, doing random stuff, but this is actually just teaching you the algebra behind using like functions. What you're doing, you're doing something, but you don't know what you're doing. But what you're actually doing is you've got like quadratic functions. If you plot like these graphs, if you plot this, then it looks like this, and those 2 points where the graph will intercept with the x-axis, that's actually like what you're solving for here. So yeah, there's a method to the madness. Like, so that's what's going to happen in later years, but just so that you don't think you're doing random stuff for no reason. Okay, then when you have this, this is just the same as like x minus 4 next to each other. So it's going to be the same solution. Basically what happens is the graph would just lie with the turning point there. So this one, you can basically just do it once. You can just say, well, if you want to, like, we know that the the square root of 0 is 0. So if you like square root both sides, you'll have x minus 4 equals to 0, and then x equals to 4. And then the same with d. 3x equals to 0, or 6x minus 8 equals to 0. Because 3x is the one factor and 6x minus 8 is the other factor. So 3x equals to 0, or 6x minus 8 equals to 0. So x is equal to 0, or take the 8 over, 6x equals to 8, divide both sides by 6, x equals to 8 over 6, and simplify, that equals to 4 over 3. Okay, done. Now the fun can start. Now we can start factorizing. So remember types of factorizations: common factor, difference of squares, quadratic, and grouping. Not very likely to find. Haven't seen a lot of grouping type of factorization in quadratic equations. But first one, if we look at A, no common factor, two terms, so the difference of squares. So we'll just say x plus 5 and x minus 5 equals to 0. So x plus 5 equals to 0, or x minus 5 equals to 0. When you get to later grades, like this step is actually like you get so used to it, like you don't do this step. You literally just go and say x equals to minus 5, or x is equal to 5. Okay, and then B. Now, this is the other thing. When we do quadratic equations, we actually want to, like we went back, like if we go back to the original principle, we want factors to equal to 0. So we want to take everything, all the terms, to the one side. So if I have minus 2x squared minus 8x equals to 0, got all the terms on the one side and then factorize. Now, something that's nice about equations, also you can drastically like simplify them before you factorize, because unlike an expression, we can't just like divide and get rid of stuff, but because it's an equation, you can, what you do on the one side, you do on the other side, it will still be balanced. So if I go divide every term by minus 2 first, just to simplify things, then those will cancel. So we're left with x squared, okay, this complicates things. Okay, plus 4 equals to 0. Okay, this one is, this one can't actually, oh, this is a x, sorry, never mind. That was my stupidity. So this would actually just be, I thought it's going to end up with, but I didn't see that x there. Okay, so this is just a common factor, not difference of squares. If that x wasn't there, but then because of this plus, we wouldn't have been able to factorize it if it was difference of squares. It has to be a minus. So taking out the x, we have x plus 4, and then x is equal to 0, or x plus 4 equals to 0, so x is equal to minus 4. Okay, so for C, now that is quadratic factorization. So factors of 8 to get 2, so 1 and 8, 2 and 4. So 2 and 4 can give me negative 2, so minus 4 plus 2. So I go x plus 2, x minus 4 equals to 0. So x plus 2 equals to 0, or x minus 4 equals to 0. So x is equal to minus 2, or x is equal to 4. All right. Last one. Now, also something that catches a lot of people out. Some would say, like, I think they're probably not like, yeah, I think that like maybe they didn't know like this concept holds only for zeros, but sometimes I've seen this, people would say, okay, x equals to 6, or x plus 5 equals to 6, but obviously that won't work because it only works like with 0. So in this case, we have to put it like in standard form first, meaning standard form is like when you have a quadratic equation where you have ax squared plus bx plus c, where a, b, and c is numbers. Okay, so this is your standard form. So meaning we have to multiply the bracket out first and then take everybody to the like one side and then factorize again. So x squared plus 5x minus 6. I'm going ahead, sorry, equals to 6. So multiply it out the bracket, and then take the 6 over to the other side. So x squared plus 5x minus 6 equals to 0. Okay, now factorize again. Factors of 6, 1 and 6, 2 and 3. To get plus 5, well, we can use plus 2 and plus 3, but we can actually not, because the signs must be different because of this negative. So we have to use the plus 6 minus 1. So this one would be, if this was a plus, you'd use these two. So this is going to be x minus 1, x plus 6 equals to 0. So yeah, x equals to 1 or x equals to minus 6.